Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the friction in one shot. There are separate videos on each topics, that is kinetic, static, rolling friction, its cause and directions, and friction in vertical surface, friction on rough inclined plane, and friction between two blocks, friction between three blocks, etc. etc. Now today I will teach the whole friction theory class for required for NEET exam. What important topics, what important theory and problems required for NEET exam I will discuss in one shot. Now let's start about the class. What is so cause of friction? Every surface is rough surface, and when a body is rest on a surface, then and a force is applied, then friction acts between two surfaces. If there is no external force, no friction acts. No external force, no friction acts. When the external force try to pull the body, then friction start to play. The friction start to play. The friction start to act. Now, what is the cause of friction? So here, when the body try to pull in this direction, a contact phase. This is the contact surface. A contact force always act in the normal. This is contact surface, so normal is this direction. This is contact force. Contact force always act between contact force always act perpendicular to the contact surface. Okay. Now the component of the normal vertical component and horizontal component. Vertical component is called normal direction and horizontal component is called friction. So when the body pulled with an external force, then the opposite force which opposes the external force is friction force. This is the friction force. So and this angle lambda is called angle of friction. Angle of friction, F is friction force and N is normal direction. Normal direction. Now you have to understand the basic concept of friction. There are first step by step I discuss. First, static friction. Suppose the force is gradually increased, and what first static friction acts, then we get limiting friction, that is maximum static friction is limiting friction. Next, when the body moves, then kinetic friction, we get kinetic friction, and there is a rolling friction. So static friction, first we get the static friction. When static friction acts, when external force is applied, when external force is applied, but the body is rest, body is at rest, then static friction acts. Now what is the friction? Static friction, Fs equal to external force. So static friction, formula of static friction equal to external force. When static friction acts, when the body is at rest, then static friction acts. So static friction is external force. Now the force is increased, and at the point, at a certain value of F, the body at the point of motion, that is the body just, when the body just to move, then limiting friction is produced. When the body is at, so you remember that condition, at point of motion, then limiting friction acts, then friction is maximum, that friction is limiting friction. limiting friction is proportional to normal reaction. Limiting friction equal to mu s into n. What is mu s? Mu s equal to coefficient of static friction, and n is normal reaction, which is generally mg. So if the body is in ground, then normal reaction and mg equal, that is mu s into mg. So this is the limiting friction, is called denoted by mu l. Static friction is fs, limiting friction fl, kinetic friction fk. Now what is the value of kinetic friction? When the body moves, then friction acts is kinetic friction. When body moves, then friction between two surfaces, then friction is kinetic friction. What is the value of kinetic friction? The formula of kinetic friction is mu k into n, mu k into n, mu k into n. Okay, so limiting friction is greater than kinetic friction, and kinetic friction, static friction, kinetic friction, maximum static friction is called limiting friction. Static friction is adjusting, static friction fs less than fl, and kinetic friction less than limiting friction. So fk, fl greater than fk, and static friction is less than limiting friction. Static friction is adjusting force, that is varies with external force. Limiting friction is constant, which is maximum static friction. Maximum static friction is limiting friction. So when the body start to move, then friction is called limiting friction. Maximum static friction mu s into n. So generally we use this formula, but different condition is given when when body is rest. We have to understand when the body is at rest. We have to understand, then we apply static friction or limiting friction or kinetic friction. Now friction is 0.1, and if same body, now if the force 200 Newton acts on the same body, 100 kg, and coefficient of friction is 0.15, suppose mu equal to this, suppose mu equal to 0.1, same value. Now what is the friction force acting in case A and B? Question is, what is friction force? Friction force acts for A and B. In two cases, what is the friction force? Now first we calculate maximum friction force, limiting friction, which is equal to mu into mg, that is 0.1 m 100 into this. First we calculate the limiting friction, that is maximum 100 Newton force can oppose the motion of the body. Now 15 Newton force is less than 100 Newton, so body is at rest. Now if the body is rest, what is the friction force? So for case A, friction force equal to static friction, which is equal to external force, that is 50 Newton. So in case A, the answer friction force equal to external force, which is 50 Newton. And for B, now here maximum friction force act 100 Newton, but the force applied is 200 Newton, which is greater than 100 Newton. Now so the body can move. Now the friction force is maximum value, which is mu into mg, that is 100 Newton. So for case B, answer is 100 Newton. Okay. So we have to understand that if the body moves or it at rest. When the body is at rest, then friction force is equal to external force, and when the body moves, then we can use friction force equal to mu into mg. Now minimum force required to pull the body in along rough inclined along rough surface, plane surface. Suppose this is a surface and body is rest on the surface, rough surface. So a force is applied at an angle theta. What is the minimum force? Find a minimum to pull the body. How can we calculate the minimum force? Now here different force acting in this direction, normal direction n act, normal direction act in this direction, weight mg. If we now resolve the force along this direction and this direction, f cos theta, in this direction f sin theta. Now the body will move under this force. The body can move along this surface. So this is the external force which causes the motion of the body. Now here normal direction and n plus f sin theta 2 will balance the weight. So n equal to mg minus f sin theta. Now friction force act in this direction, which is equal to mu into n. So what is the force required to move the body? This force must be equal to this. So to move the body, f cos theta must be equal to mu into n. Now n equal to this f sin theta. Okay, so shift f here, cos theta plus mu sin theta equal to mu mg. So f equal to mu mg divided by cos theta plus mu sin theta. Here two case may be arised. So answer is, NEET student, remember this formula, or if you cannot remember this formula, then just write the two equation, this and this. Write the two equation. From two equation you get the force. Now what is the formula of force? So force required equal to mu mg divided by cos theta plus mu sin theta. So this is the answer. Now two case may be arise. So this is the formula when theta is fixed. Suppose theta is given, theta a force is act at an angle theta. So what minimum force is required to pull the body? So theta is fixed, then this is the answer. But if you are not asked the theta, that is you may vary the theta. When theta varies, then what is the minimum value? Now this numerator denominator. So if the denominator, that is if this expression is maximum, then force will be minimum. So f minimum equal to this divided by minimum of this. What is the minimum value of this? Minimum value is 1 plus mu square, because there is a formula in trigonometry, a cos theta plus b sin theta, maximum of this equal to root over a square plus b square. So I have applied this formula. Here a is 1, b is mu. So maximum value of this expression is this. So this is the minimum. So when theta varies, a minimum is this. You can remember this formula. And when theta is fixed, then the formula is this. Along rough inclined plane. What is the acceleration along rough inclined plane? Okay. So if a body is placed on a inclined plane, rough inclined plane, suppose this is theta, what force act on this body? First, mg act in this direction, mg sin theta in this direction, and friction force act in this direction. What is friction? Friction equal to mu n. Here normal direction is in this direction. which is equal to mg cos theta. So if mg sin theta greater than friction force, then the body accelerate along this direction. What is the acceleration? So if the acceleration is a, then ma equal to mg sin theta minus mu into n, which is equal to mg sin theta minus mu into n. What is normal direction? Normal direction is equal to mg cos theta. So a equal to g sin theta minus mu g cos theta. So this is the answer. You remember this acceleration formula. This equal to this. Now when body is projected upward, what is the retardation produced? When body is projected upward, find retardation produced. When the body is projected upward, now this when the body is projected upward, then friction act in this direction. So this is the friction force. When body is projected upward, then friction force act in this direction, weight act in this direction. So if the retardation is a, then ma, that is these two force opposes the motion of the body. These two force retard the motion of the body. So ma equal to mg sin theta plus friction force equal to mu mg cos theta, mu n mg cos. So a equal to g sin theta plus mu g cos theta. So when the body is projected upward, the retardation is produced. This is very important theory for NEET exam. Acceleration, when the body moves along downward, acceleration equal to this, and when the body is projected upward, the retardation produced with velocity u. This is theta, and coefficient of friction along rough plane is mu given. When the body returns back in this position, when the body returns back, what is the velocity? V equal to what? U is given. The body is projected with velocity u along the rough surface. When the body returns at this position, at the point of projection, then what is the velocity? Here, what is the distance travel? The distance travel where velocity is 0. So first find the distance travel s. So for upward motion along plane surface, along inclined plane, what is the motion, equation of motion? V square equal to u square minus 2as, v equal to 0, u equal to u, and a equal to, just I have derived in previous topics, a equal to g sin theta plus mu g cos theta. Retardation is produced this into s. Now so for s equal to u square by 2g sin theta plus mu cos theta. So s equal to this. Now when the body returns at its initial position, what is the velocity? Now use the equation v square equal to u square plus 2a dash s, v square equal to 0, because here initial velocity 0 plus 2a dash. Now when the body moves along downward along the inclined plane, then acceleration equal to g sin theta minus mu g cos theta, and s you put here s u square divided by this. So cancel 2g. So v square equal to this. So v equal to u into root over sin theta minus mu cos theta divided by sin theta plus mu cos theta. So this is the answer. When the body returns this, the velocity becomes this. If the surface is smooth, then mu equal to 0. Then if the surface is smooth, then what happens? Mu equal to 0, so v equal to u. But if there is friction in the rough plane, so then the velocity will be u into this. Now if we put mu equal to tan lambda, so there is a formula, coefficient of friction equal to tan lambda, where lambda is angle of friction. And if we put tan lambda, if we put mu equal to tan lambda, then what comes here? V equal to u into, put tan lambda here, you get sin theta, sin lambda by cos lambda, sin theta minus lambda by sin theta plus lambda. So this is the answer. Okay, this is the answer. This is equilibrium of body along rough inclined plane under an external force. Equilibrium of body along rough inclined plane under an external force. Okay, now suppose a body is placed in an inclined plane, angle of inclination is theta. Now mass of the body is m. Now for mg sin theta, body try to move along downward. Now an external force act in the opposite direction, hold the body in the body is in rest, that is the body is in equilibrium under the external force. Now two cases may be arised. First, when at a particular force the the body try to tends to move, the body tends to move downward. This is the tends to move downward, but the force applied on the body holds the body, is at rest, holds the body. That is, this force prevents the motion of the body along downward. So what is the force required? Now F1, if the if the body tends to move downward, what is the friction force? Which direction friction force act? In this direction. When the body tends to move, not in motion. Point to remember, the body is tends to move. Tends to move means it has a tendency to move, but it is not in motion. So if the body tends to move downward, what is the friction force? What is the direction of friction force? This direction. Now here F1 plus friction force balance the mg sin theta. So F1 equal to mg sin theta minus friction force, which is mu mg cos theta. So along inclined plane, we know friction equal to mu mg cos theta. So this is the answer. Now second case, suppose force is increased at a particular value of F1. Now the body tends to move upward. At a particular value of F2, suppose F2, the body now tends to move upward. Tends to move, not in motion. Now the force is some more than F1. If the body tends to move upward, then friction force act in this direction. So here F2 will be mg sin theta plus F. That is mg sin theta plus F means mu mg cos theta. So two force required. The body is in equilibrium, the body is at rest under these two force, but just friction is adjusting force. It may change the direction when it can change the direction, depends upon the external force applied. So this, so F1 and F2 we get, what is the ratio of F1 and by F2? If we divide this by this, we get g sin theta minus mu cos theta divided by sin theta plus mu cos theta. If you put mu equal to tan lambda, then sin theta tan lambda, theta minus lambda, theta plus lambda, you get F1 by F2 is in the ratio this. Next topic is equilibrium of body along vertical surface along vertical surface, rough surface, vertical rough surface. Suppose this is a vertical wall and a body is placed, the body is held against the vertical wall by applying a force. This coefficient of friction is mu. Now here what is the normal direction? Normal direction act in this direction, which is equal to F. So action reaction. Now the body try to move due to its own weight, and friction force act in the opposite direction, prevents the motion of the body. So friction equal to here mg, and friction equal to mu into F mg. So F equal to mg by mu. So this is the answer. This force required to hold the body. Now if the force is applied, suppose this is a body, the force is applied at an angle F, this is the angle, then what minimum force required to hold the body? Here if we resolve force, this is F cos theta and this is F sin theta. Weight act in this direction and normal direction act in this direction. Now here normal direction equal to F sin theta, but here F cos theta, weight act in this direction, the friction force act in this direction, weight act in this direction. Here F cos theta plus friction balance the weight. F cos theta plus friction balance the weight mg. Okay. Now F cos theta plus F, which is friction force equal to, we know mu into n, n is F sin theta, balance the weight. F cos theta plus F equal to mu into n is F sin theta. So F here equal to mg divided by cos theta plus mu sin theta. So this is then two blocks resting on one on other, other. Here different case may be arised. Suppose this is a ground, two blocks are present, this and this, Suppose this is smooth surface and a friction is here. Suppose this is friction. I consider the general case. What happens if friction is there and this is smooth surface, m1 m2, mass of two blocks. Now if F is applied on this block, what happens? First draw the free body diagram. M1 M2, external force act in this direction. First this body try to move over this surface. This is general concept, practical concept. If a force is applied on this block, first this block try to move, not this. First this block try to move along this direction. So here if the block try to move over this surface, then friction oppose its motion. So friction act in this direction, which is equal to mu m1g. Okay, simple case. Just think practically. If the force is applied on the block F, then this block try to move over this surface. So obviously friction here always the motion of the friction here oppose the motion of the body. So this is opposing force. Now this opposing force drive the motion of the body, that is in contact surface. If this is action, this is direction. So now this is mu m1g, this is driving force. For m2. Now if suppose friction is less, suppose external force is less, two cases may be arise. Suppose calculate mu m1g, this value is 10 Newton and this value is 2 Newton. What happens? That is the block does not move over the surface because friction opposes the motion. The applied force is not sufficient. So if F less than mu m1g, first I consider F less than mu m1g. So the m1 does not slide over the surface m2. If the block does not slide over the M2, then M1 and M2 is will be moved together. Now if M1 M2 is M1 M2 acts as a single body which move together. Now if less than this whole two body move together, so what is the force? What is the acceleration of the two body? A equal to force divided by total mass m1 plus m2, because here no external here friction is not present, so net force is f. These action reaction cancel to each other, so here no friction force act, because the friction and this and this when is in contact cancel each other. So take this as a single body, on which force is act f, and here no friction force act, so total acceleration of the body is f by m1 plus m2. Now if greater than, first we consider this. Now if greater than, now second case, if greater than mu m1g, suppose this force is greater than this force. Now so this force, now the acceleration of this a1 and this is a2. Now what is the acceleration? Acceleration equal to net force divided by m1, this is acceleration a1, and a2 equal to mu m1g by m2. So here one force act, this is this force drives the body in this direction, so here driving force is this, so acceleration equal to driving force by mass, which is this. Now what is the maximum value of f, so that the two blocks move together up to what maximum? For less value of f than a certain value. So now what is the maximum value for which both block move together? For what maximum value of f two blocks move together? For what maximum value of f two blocks move together? Suppose we get this value is f dash. Now force less than f dash, two block move together, this is fine, and up to f dash two blocks move together. If force is greater than f dash, then two body move separately. So which I have, what is the acceleration I have discussed. Now find the f dash for which two blocks, find the value of f dash for which two blocks move together. For that, first two block move together, that is here force is applied this, and friction force act in this direction, mu m1g and m2, here driving force is this mu m2g. Now the two block move together, suppose the acceleration is a and this is acceleration a, so for both two blocks acceleration will be same, because two block move together. Now here we can find the acceleration, because here driving force is this, so m2a equal to mu equal to mu m1g. From this we get a equal to mu m1 by m2 into g. So first we find the acceleration from this block. So the step is, first consider the block at which no external forces act, because here only driving force act, so from this we get the acceleration. Now if you consider the motion of this body, what? F minus mu m1g equal to m1 into a, okay. So F equal to mu m1g plus m1 into a equal to this. This is the force. So this is the force required. This is the force required. Up to this force, two blocks move together. Up to this force, two blocks move together. After that force, two blocks move separately. So what is the maximum value for which two blocks move together? If you are asked, then first step is first draw the free body diagram and first find the acceleration at which no external force is applied. At which no external force is applied. Where no external force applied here. So from this we get the acceleration. Now m2a equal to mu m1g. So a equal to this. Now write the equation of the motion. F minus this equal to m1a. So F equal to this plus this and put acceleration at here. You get the result. So this is the minimum. This, for that force, up to that force the body will move together. After that force, that is the force greater than this value, if the force applied greater than this value, then the two block move separately, that is move with different acceleration. This is the end of the class. The main important theories have been discussed. What is required for NEET exam? Now the important problems for NEET will be discussed in another video. Okay, thank you.